Okay, see 90 degrees, 90 degrees. Okay, this force is, let us say, F1, this is F2, this is F3, and this point, right, maybe some joint, this is three forces are acting at some joint, F1, F2, F3, they are perpendicular like this. And this point is in which equilibrium? Static equilibrium. Because a joint is in static equilibrium. This is in static equilibrium. And there are only three forces, F1, F2, F3 in that fashion, perpendicular to each other. Now, what is the relation between them? If you can find the magnitudes, find out. Are you okay? Listen. As it is in static equilibrium, right? So in x direction, first, it is a coplanar concurrent force system. I have two equations of equilibrium. They are sigma fx 0, sigma fy 0. So in x direction, as it is in static equilibrium, what can I write? Sir, listen carefully. Sigma fx equal to 0. Out of the 20 questions, whatever comes in the exams, let us say 10 questions, whatever is coming, 50% of the questions will come only from this topic, and you can answer in 10 seconds, not even 11th second. Listen carefully. Sigma fx is equal to 0. What I can write from sigma fx equal to 0? F1 is in this direction, positive. F1. F3 is in the opposite direction. Minus F3 is equal to 0. So what is that? F1 equal to F3. So from this, what I can conclude? First point. These two are having equal magnitude. Next, in y direction, listen here, y direction, it's in static equilibrium, right? So what are the forces in y direction? Sigma Fy equal to 0. What are the forces in y direction? Only one force, F2, and that is equal to 0. What's a beautiful conclusion I can make from this? Whenever there are three forces acting at a point in this fashion, two are in a line, and third is perpendicular. These two should be equal, and the third force is 0. I said when I am saying Lami's theorem application, or if three coplanar concurrent forces are there, for the system to be in static equilibrium, all the angles should be less than 180, not even equal, less than 180. If not, see, the third force became 0, because there is a possibility these two are in a line. So this force is not there, it is 0. This force is not there, it is 0. Two forces only are there. Both are equal in magnitude, opposite in direction, same line of action. This is 0. Even though the member is there, the load is 0. That member is called zero force member. These members are called as what? Zero force members. Now, listen here carefully. Listen. If suppose they are not like that. They are in this fashion. F1, F2, F3. Okay, this angle is theta. See, these two are in line. This is not. Now it's not perpendicular. It is inclined at an angle theta. Now what happens? Still this is in which equilibrium? Still it is in static equilibrium. Now do the problem. Tell me what we can do. First, what to do whenever something is inclined? First resolve it. I will resolve this. If I resolve this, see, one component like this. What is this? Opposite side. So this is F2 sine theta. And one more component here. That is F2 cos theta. Adjacent side cos theta. Now write the equilibrium equations. So first I will write in y direction because I don't. First I will write in y direction because I don't want to carry. Okay. So first in y direction. Static or dynamic equilibrium? Static equilibrium. So sigma Fy is equal to 0. Tell me what are the forces in y direction? Only one force, that is F2 sine theta, that is equal to 0. F2 sine theta. See, any one of them should be 0, but here sine theta is not 0 because it is having some angle. Only at theta equals 0 it is 0, but theta is not 0. So sine theta is not 0. Who should should be 0? Who should be 0? F2 is 0. F2 is 0. So this force is 0. This force is 0. Now if F2 is 0, what will happen to F2 cos theta? That is also 0. If F2 is 0, F2 cos theta is 0. Now what's happening in next direction? Static or dynamic? Again static. Sigma fx equal to 0. Sigma fx equal to 0. So F1 positive direction, F3. F2 cos theta gone. So F1 equal to F3. So not only perpendicular, not only the second force need to be perpendicular, even if it is inclined also, if two are in a line, if two forces are in a line, see at a joint there are only three forces. If there are less than 3, more than 3, I don't know. If there are only 3 forces, and two of them are in a line, the third force need to be 0. Right? It is perpendicular, inclined, no matter. The third force need to be 0. This is the first beautiful point. When there are only 3 forces at a joint, and two of them are in line, the third is 0, and those two are equal, and those two in line are equal. That's a beautiful point. Next. Listen. Not yet done. Listen. At this joint, 1, next 2, 3. Okay. Listen. Let us say this angle is theta. Some angle theta. F1, F2, F3. Now let me solve first. Then I will tell you. So what to do? First, if there is an inclined force, resolve it. If I resolve this is also in which equilibrium? Static. Okay. Now what is this going to be? F2 cos theta. And what is this going to be? F2 sin theta. Now, first write down the equilibrium equations. X direction, static or dynamic? Pakka static equilibrium, because truss everything is at static. Sigma fx equal to 0. F2 cos theta, positive direction, so plus F2 cos theta plus F1 is equal to 0. Let us say first equation number 1, keep it. Y direction, static or dynamic? Again static equilibrium, so sigma Fy is equal to 0. Tell me now, what are the forces? F3 plus F3, F2 sin theta, that is also up, plus F2 sin theta is equal to 0. Okay, so let us say this is equation number 2. Now see, it's not directly 0. I will make 1, 4, 0. I am giving. Somehow I know. 1 force is 0. Which force? First let me make first case. Case 1. First case. F1 is 0. What happens if F1 is 0? This is 0. That means F2 cos theta 0. F2 cos theta 0. So cos theta is not 0. Who will be 0? That means F2 is 0. If F2 is 0, who is 0? F3 is also 0. That means if F1 is 0, these two are 0. Next, case 2. I'm making F2 0. So what will happen if this is 0? F1 is 0. F3 is also 0. Okay. Next, third one case. If I make F3 0, if this is 0, that means sin theta is not 0. So F2 0. If F2 is 0, then F1 is 0. That means not only in this fashion, let them be in any fashion. What do you mean by any fashion? Even like this. Even if it is like this. See, now what happens? Anyway, not only like this. Let them be in any fashion. See, P by, what's the formula? P by sin alpha equal to Q by sin beta equal to R by sin gamma. If any one of the forces is 0, when our three forces are acting, let them be in any fashion, but there should be only 3. If any one force is 0, not except they are in line like this, they should be inclined. Like this. Okay, perpendicular, inclined, whatever it is, except 2 are in line. If they are in any of these fashions, if one force is 0, remaining two are 0. If one force is 0, remaining two are 0. But here, if they are in line, Those two are equal, third force is definitely 0. They two are equal, third force is 0. Are you okay? Are you okay? Finally, I'll say one more last point. Here I'm not going to derive. See, if suppose I have at a point, just for simplification, so that you will have an idea, you can get this, but still, if suppose I have four forces like this. I have four forces like this. F1, F2, F3, F4. So I am not going to write, in exam, don't sit and write X and all. See, if they are like this, definitely I can say, see, from sigma Fx equal to 0, these two are equal. From sigma Fy equal to 0, these three are equal. Okay? So I'm giving three beautiful points for now. What are the three beautiful points? If there are only three forces at a joint, and two are in line, the third force is 0. Let it be in any way, the third force is 0. At any angle, third force is 0. If there are three forces at a point, second point, if there are three forces at a point and they are not in line, two are not in line, but they are some way, let them be in any way, but they are not in line. If any one force is 0, then remaining two are 0. And this is the last one. If they are perpendicular like this, four forces, opposite forces are equal. These two are equal. Okay? These are very, very, very important problems. Please, all of you, see what I told. If there are three coplanar concurrent forces and two are in line, where there are three forces, see, at D, F1, F2, F3, there are three members connected at this point D, and two are in line. As these two are in line, both will have equal magnitude, and the third force will become 0. That's it. Anything else? Anywhere can you show me? There are three in line. Three coplanar concurrent forces, two in line. See, listen. As F3 is 0, remove this force. Now remove this member. Now what is happening? No, actually I won't remove for the timing, as it is 0. Now it's not there. Now it is not there. Then what will happen? See, again, 1, 2, 3. So these two are in again line. So the third member, this is the third member. This is also 0. All of you are okay? So what's the answer? So F3 and F4 are equal to 0. Okay? So the 0 4 members in the truss is F3 and F4. See, for this loading system, AC and CD are 0. But now see here. All of you see here. As usual, as you say, these two are in line, AE and BE. There are only three members. AE and BE are in line. So this member DE is 0. Now as this member is 0, it is removed. These two are in line. CD, DB are in line. So they should have equal force. These two are in line. This is the third member. The third member will become equal to 0. Listen. At C. What's happening at C? How many forces are there? Load W, member AC and member BC. How many are there? Three forces. Two are in line. See, this should be equal to this. That means the load in this member is W, and this will become 0. Already we know CD and DB are in line. These two should be equal force. So that is also 0. Now listen. Now come here at B. How many forces are there at B? Actually BD, BE, and one more force is what? Support reaction. One more is what? Support reaction. What is a support reaction? RBY. Now please see. 1, 2, 3. Three forces. If one force is 0, if remaining two are in line, then they will be equal and opposite. But they are not in line. That means these two also should be equal to 0. Three forces are there, coplanar concurrent forces. If any one of them is 0, if they are not in line, and if any one of them is 0, remaining two are 0. If this is 0, this is also 0. Okay, not only that one, if you go for the support reactions, even RAX is 0. The load will be straight away going to this with support A, and RAY is equal to RAY is equal to W. Area is equal to W. So except this number 1, 2, 3, 4, 5, 6. All the six members are having zero load. All the six members are having zero load. 6 members are having zero load. No. Listen, where are the 3 members? Start from here. See, AD and DF. AD, DF. These two are in line, and the third member. See, at D only 3 are there. These two are in line, and this will become 0. This will become 0. Now, as this is removed, Look at C. These two are in line, and this member will become 0. Now, come here. How many are there? 1, 2, 3, 4. No. Now go here. See, 1, 2, 3. 3 members are there. These two are in line. So this will become 0. This will become 0. Okay. Now, as this is 0, these two are in line. As these two are in line, what happens? This member will become 0. Now see at F. This is 0, this is 0, this is 0, this is 0. How many are left out? 3. As 3 are there, so these 4 will be having same force, and this will become 0. Are you okay? And as it is symmetrical, even these members will share the same load. They will share the same load. You just find out here. Apply the coplanar, system of coplanar concurrent force system. You can, resolve the two forces and equate them. You'll get equal magnitude being transferred. Okay. So how many members in total? 1, 2, 3, 4, 5. Complete the inside, whatever is there, there will be 0. Load will get transmitted like this. Are you okay? Now, similarly, I'll quickly solve them. This is also a similar question, so I'm not going to waste time. Please see here. See, these two are in line, AD and DF. So CD will become equal to 0. Now, as this is 0, AC, CE, both are in line. So what will happen to the third member? That is CF. Again 0. Now, if this is 0, DF, FH, they are in line, and the third member will become 0. If this is 0, CE, EG, both are in line, so this will become 0. Similarly, come from this side. These two are in line, so this will become 0. Again, these two are in line, this will be 0. And again, these two are in line, so this will become 0. Again, these two are in line, this will become 0. See, when this is 0, there are only 3 members. 1, 2, 3. 2 are in line, third member is 0. Now check here. Actually, 1, 2, 3, 4, 5 are there, but 2 has gone already. How many are there? Only 3. So these two are in line, so the third member is 0. So whatever is there inside, all these are equal to 0. Okay. So the load will be again transmitted like this. All of you. See, sir, many times people has asked me one doubt when I have kept this question. That's why I have given you. See, sir, at this junction there are 1, 2, 3, 4, 5 now. 1, 2, 3, 4, 5 and a load. So how it can be 0? Sir, see, whenever there is a body, it's an action-reaction pair. So when you are applying a load here, only if this end can bear, then it will take the load. As this end both are in, 3 are there, these two are in line, and the third member is 0. So here it cannot take the load. The load will be shared by C, F, GF, DF and FH. The 4 members will share the load, but this member will not take any load. Are you getting me? Right? So it is kept to support this CG, only to support this CG. When it gets deflections, we have kept it. Because see, if I remove this member EF, it will become a long member. So I don't want that. So I have kept it here. Okay. So they have some other purpose. So even though at one end there may be load, but still, if at one end also if it is having T junction, I mean 3 forces are there, 2 are in line, and the third will definitely become 0. Even here, this will be 0 because at H, these two are in line, this is 0. These two are in line, this is 0. So CD, EF, GH. So 1, 2, 3. So what is the answer? B. C. Okay, fine. We know CF is 0 because there are 3. This is 0, no doubt. Okay, fine. That's fine. Okay, next. What else may be there? EF, AB, and then BF, right? Now, EF. Where is EF? This is EF. Now see, is there any chance at this end? 1, 2, 3, 4, 5. Very good. Come here. What is this support? What is this support? Roller support. At a roller support. How many support reactions it can maximum offer? Only one support reaction. How is it? In this fashion. Now, How many are there? Total forces 1, 2, 3. So these two are in line. This number will become 0. No need even to check AF, AB and BF. Just this is done. This is the last question. It's a simple one. Tell me. The stress in the rod AB of the diameter D in the pin jointed truss ABCD. Even though he's asking stress, how? Simply stress is nothing but force upon area. He didn't give area. Why? Let us check it out. He's asking the rod AB. Where is AB? This is the rod AB, right? This is the rod AB. Now tell me, what is happening at A? It's a hinge joint, 2 support reactions, 1, 2. So total 4 plus 1, 5 are there. Now come at B, 1 and 2. This is a roller support. As this is a roller support, only one support reaction. These two are in line. This is 0. If the force is 0, what will happen to my stress? That is also. If the force itself is 0, what will happen to my stress? Force is 0, so what will happen to my stress? So that is also 0. All of you okay? Number of zero force moments in the truss for the given loading is. See where I can start. Where there are only 3 members in line. Only one place is there. See this place. What is happening at this place? These two are in line. The third member will become 0. These two are in line, the third member will become 0. One sec. Two are in these two are in line, so the third member will become 0, right? So this is 0. Apart from that, so this is gone. Next. Anything else? Here, this is roller support. If I take even one, still how many are there? 1, 2, 3, 4. I cannot say. Here, it's a hinge support. There are how many? 2 support reactions. Very good. I don't know which one is 0 and all. One way is you can say, if you write sigma fx is 0, the only force is this one. From this you can start, but I won't suggest that. See, listen. At G, how many are there? 1, 2, 3. As there are 3. One of them has become 0. One of them has already become 0. Now how many are left out? Remaining 2. What will happen these two? No, let there be 3 coplanar concurrent forces. If any one of them is 0, the other one will become definitely 0. Why? See, these two are not equal in magnitude and opposite in direction. So they cannot be there. So they have become 0. See, when 2 forces can keep the point in static equilibrium, when they are equal in magnitude, opposite in direction, same line of action. So they don't have that possibility. Hence they should be 0. So these 3 are gone. Next. See, if this is gone, what happened here? These two are in line. Again, these two are in line. So what happens? This number is 0. If this is 0, come to E. This is already gone. 1, 2, 3. This is 0 now. So these two also should be 0. Again, come. See, what's that? BF, DB, BC. These 3 are there. Now this has gone. This is 0. This is gone. Now what will happen? These two are in line. So this number will become 0 again. Now if this is 0, what will happen? How many are there? See, this is already gone. CA, CB, CD. In that this number has become 0. So the remaining 2 also should become 0. Next, again, if this is 0, how many are there? See, these two are in line. The third member is 0. I want only numbers. I don't want support reactions. Even if you go, this reaction is 0, this reaction is 0. Because how many are there? 4 are there. This is equal to this. This is equal to this. Already I proved that. So only count numbers. How many are there? 3, 6, 9, 10. That's it. And this is nothing but equal to W. This is nothing but equal to W. This is nothing but equal to W. This is also W. The load will be transferred. So 3, 3, 6, 9, 10. So what's the answer? Okay. Hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.